Good morning, everyone. Myself, Dr. Aves Ahmed Husseini, working as a head of department in Automation and Robotics Department at Sharad Institute of Technology, College of Engineering, Edrao. Today, we are going to discuss about introduction about fluid mechanics and thermal engineering. So, I just move further for the next slide. In this particular slide, we are going to discuss about some overview or some fundamentals related with the two. The first one is a fluid mechanics and second one is a thermal engineering. So as far as that fluid mechanics is to be concerned, it includes different properties of the fluid like density, mass, specific gravity, dynamic viscosity, kinematic viscosity, surface tension, capillary action, compressibility, vapor pressure. This particular part is included and it is a heart of the fluid mechanics. You must have to know the different properties of the fluid along with their units and their relevance as well. Also, this particular part consists of the fluid statics. Okay, so there are basically three parts: the fluid static, fluid kinematic, and fluid dynamics. Okay, so in fluid static, it's related with the different laws like Pascal's law. Again, it includes pressure at a point, total pressure, center of the pressure, along with some effects like buoyancy as well as metacenter and metacentric height and flotation. This particular part is included in fluid mechanics as a fundamentals. Again, when we discuss about the introduction about the fluid kinematics, so it includes different equations like continuity equations along with the different fluid flows. That fluid flows includes n number of the flows like laminar flow, then turbulent flow, transient flow. Again, it includes uniform, non-uniform, one-dimensional flow, two-dimensional flow, three-dimensional flow, along with steady as well as unsteady flow. Also, it includes that compressible as well as incompressible flow. This particular fundamentals of the fluid mechanics is also deals with a number of the equations like Euler equation. Okay, and in that Euler equation, we are going to study the motion of the particle and we can determine their performance as well. Also, this particular unit consists of derivation of the Bernoulli's equation. As we know that there are a number of applications of the Bernoulli equations like Pitot tube, then venturimeter, orifice meter, these all are the flow measurement device. So in this particular Bernoulli's equation, we are going to discuss about various applications as well as we are going to discuss that particular n number of the numericals related with the Bernoulli's equation. Similar way, that particular part consists of different pipes, the study of the different pipes and internal flow. So as we are aware about different equations which is related with the fluid flow and the different pipes is Darcy equation as well as Chase's equation. It will give us the information about the different losses. Okay, also it includes some part of n number of the different pipes like series pipe, then parallel pipe, equivalent pipe, then siphon pipe. These are included in this particular flow through pipes. And when we are talking about the types of the pipes, then definitely one question is arising. It's related with the losses. So there are basically two types of the losses. The one is major losses, which occurs because of the friction between the surface and the fluid. And another one is the minor losses, which occurs because of various reasons like bend, then elbow, sudden contraction, sudden enlargement, as well as entry, as well as exit. Okay, so it's all are about some basic overview about fundamentals about the fluid mechanics. And when we are going to discuss some latest and modern part of the fluid mechanics, so definitely it include the concept of the drag and the concept of the lift. So it's related with the practical applications like aeroplanes and kites. Okay, so this part is most important as well as that particular fluid friction and pressure drag is to be concerned, right? So various theorems like Buckingham's theorems, pi theorems, as well as types of the simulation which is related with the drag and lift force, we will discuss in this particular point. And when we talk about the fundamentals about the thermal engineering, then it include the various laws actually. So as we know that there are basically three laws of the thermodynamics: the first law of thermodynamics, the second law of thermodynamics, and third law of thermodynamics, that we are going to discuss in thermal engineering. Just I move further for the next slide. Then what is the objective of this particular subject, that is fluid mechanics and thermal engineering? So the basic objective is understand the fluid properties and the behavior. The second objective is analyze thermodynamic system. So thermodynamic system means what? The system, what is exactly the system is? The system is a region or the space where actual thermodynamic process is carried out. So it is called as a system. So there are a number of the systems like open system, closed system and isolated system that we are going to discuss in this particular objective. As far as that particular first objective is to be concerned, it includes different fluid properties. So in unit number 1, we are going to discuss the various fluid properties like density, specific gravity, capillary action, surface tension, compressibility, uh, different types of the viscosity as well. Okay. And the third objective is related with the apply the laws of the conservation. Okay. So it include the first law of thermodynamics, second law of thermodynamics, third law of thermodynamics. Similar way, these laws are also related with that particular fluid mechanics as well. So in that fluid mechanics, we are going to study some energy balance equations like in Euler's equation as well as Bernoulli's equation as well. Okay. Then the fourth objective, as far as that our curriculum is to be concerned, is understand the heat and mass transfer. Basically, these two concepts are different, but major contribution is related with the heat transfer. So in this, we are going to study the different modes of the heat transfer, that is conduction, convection as well as radiation. And the next objective is solve the engineering problems related with the fluid and its energy relations, along with different numericals which are related with compressors as well as heat transfer. Now I move further for the next important part, that is important in the engineering. What is the scope of this particular subject in engineering? So as we know that HVAC, that is heating, ventilation and air conditioning, is a growing field. So you must have to clear the basic concepts related with the fluid mechanics as well as thermal engineering as far as this particular subject is to be concerned. Also, in order to clear the basic fundamentals related with the real engineering problems like IC engines, turbines, pumps, this particular prerequisite study of fluid mechanics and thermal engineering is most important. Then the third importance of this particular subject in robotics as well as aerospace and chemical industries, as well as this particular sustainable and energy efficient systems are also right now, the government is also in taken initiative to prepare or to form the sustainable solution. To prepare that sustainable solution, we must have that fundamental knowledge about fluid as well as thermal engineering. Okay, so this is all about the importance and scope in engineering. Then I move further for the next part, that is basic concept of the fluid mechanics. So as I discussed earlier, these are the basic concept, fundamental concept and prerequisites content which is required to study that applied kind of the fluid mechanics. So it includes fluid properties, that are part, this particular part is already discussed, that is density, viscosity, pressure, then surface tension, capillarity and all. Also it include the basic three types of the fluid mechanics, that is fluid static, fluid kinematics as well as fluid dynamics. Also it deal, this particular subject deal with the various equations like Euler equation, Bernoulli's equation, continuity equation. Again this particular subject deal with the flow classification, whether it come under the laminar or whether it come under the turbulence. Then the next one is the thermal engineering basics. So the very fundamentals about the thermal engineering is to be concerned, and this particular point is start with the basic concept of the heat. So what exactly the heat is, then what are the different types of the heat, then it includes the various properties then it includes the different systems. Also, it includes the different laws of the thermodynamic. The first law is there, then zeroth law of thermodynamics is there, then second law it include again Clausius statement and Kelvin Planck statement. This part is again most important to solve the real life engineering problems. So the next one is the heat transfer and its modes. So what exactly the heat transfer is, how heat transfer takes place in any kind of the state of the material, in related with the solid, related with the liquid, related with the gases, and what are the different modes of the heat transfer that we will going to discuss in that particular unit, that is conduction, convection and radiation. Then absolutely the real application of the heat transfer is one of the best application is the heat exchangers. Then how that heat exchanger works, then again the refrigeration and air conditioning play the most important role in heat transfer. So again condenser and evaporator both are one kind of the heat exchanger. So we will take the real life application of this particular thing, as well as we are going to discuss and focus on the energy conservation system again related with the heat transfer and thermal engineering. So what are the different application of this particular subject, where it is used? So the basic application, there are a number of applications, but few are highlighted here. The one is automotive cooling and heating. So as we know that we are sitting in the car and we are get comfort from the air conditioning system. So this particular heat exchanger is most important role. Again, one radiator is a one device, and it is also heart of the automobile industry to keep that particular coolant cool. So for that, that radiator is generally used along with the air conditioning and refrigeration kind of things. So that as far as that air conditioning is to be concerned, related with the automobile industry, that car radiator as well as that air conditioning system play most important role. So sometimes we prefer that the air conditioning, and in case of the winter and in case of the rainy season, we need to heat that particular car and vehicle. For that, some other techniques are also generally preferred. So it is come under the application of the thermal engineering, and also some fluids are involved, that is refrigerants are involved in it. So it again it play most important role. So the next point is hydraulic system. So hydraulic system, it include a number of the applications, heavy duty applications. It works on the basic principle of the Pascal's law. So various types of the applications like hydraulic press, then hydraulic brake, then cranes, joist, and then these are the all are works on the basic principle, working principle of Pascal's law, and it's related with the hydraulic system. Again, as far as that hydraulic system is to be concerned, the fluid play most important role. So that fluid we need to study first. Also we need to focus on their properties of that particular fluid. So for that, this particular subject is important. And when we talk about the power generation, that power can be produced by various different techniques. One of the techniques is a thermal power plant. One of the method to produce the electricity is a thermal power plant. It include different components like boiler, it include turbines, it include different kind of the heat exchanger, condensers, cooling towers, different pumps, different motors that we are going to discuss in this particular point. So as far as that aviation industry is to be concerned, so again that compressibility concept is most important. So that drag force, lift force, then its friction, the coefficient of the friction, then various theorems related with it that we are going to discuss in this particular kind of the application. Similar way that robotics and automation, fluid control. So the heart of that automation and robotics is totally governed by the fluid control mechanism. And again for that we need to study its properties, we need to study the fundamentals related with this particular fluid again. So for that, that particular fluid study is most important when we talk about hydraulic as well as pneumatic, for the application of robotics as well as that automation. Then what will be the learning outcomes? What kind of the benefit you will get at the end of this particular curriculum? So analyze the fluid and thermal system, then use of thermodynamic principle in practical engineering, then apply equation of the fluid dynamics, then you can design thermal system for the real world use. Then as far as that conclusion is to be concerned, the fluid mechanics and thermal engineering form the foundation, and it is very fundamental of the many engineering subject. Okay, so this particular subject is most important for clear your the basic concept of HVAC and R, then heat transfer and hydraulics and pneumatics. This is all are about the basic scenario about the fluid and thermal engineering. And from the next lecture, we are going to discuss unit wise or point wise content, and we are given the stress on that particular point, and we will deal with the real life application also. So, thank you, all of you, for the patience listening.